Okay, hello everyone, and welcome to the 7th challenge of Damn Vulnerable DeFi. Let's go ahead and take a look at it, and this one's called Compromise. So, while poking around at a web service, one of the most popular DeFi projects in the space, you get a somewhat strange response from their server. This is the snippet. And we get some weird, what's looking hex data here, and some more hex data here. A related on-chain exchange is selling absurdly overpriced collectibles called DVNFT. Now at 999 ETH each. This price is fetched from an on-chain oracle and is based on 3 trusted reporters. This address, and this address. Starting with only 0.1 ETH in balance, you must steal all the available ETH in the exchange. Okay, so this looks really interesting. Let's go ahead and take a look at the contract that we have. So we're going to go to Compromise, and we have 3 here. We have the exchange, a trustful oracle, and a trustful oracle initializer. So let's have a look at the exchange, because that's probably the main thing that we're going to have a look at. So we have quite a few, about 3 functions here. So we have the token, which is the Damn Valuable NFT, and a oracle, which is a trustful oracle. Some events defined here. And so we can see that when this gets constructed, it actually creates a new contract. So this contract actually deploys another contract, which is the Damn Valuable NFT. So we can actually take a look at this as well. But this is, again, kind of very similar to an ERC 721, just kind of with its own custom things here. So yeah, it's just the your standard ERC 721 NFT. So the first function we have here is buy one, and then we have sell one, and we have this is externally payable, so we can just pay this function if we want. So there's only really 2 functions here. So let's say we want to buy a NFT. So we set the amount paid in Way to be the message.value, and then we require that to be greater than 0, so we need to pay something. And the price should be Way per NFT. So the current price in Way equals the oracle.get median price of the token symbol. So we're going to have a look at that in a second. But it looks like it somehow gets the price from the oracles, and then it requires that it is at least that amount or greater. If it is, then it goes ahead and mints an NFT to us, and it then sends the value of the amount paid in Way minus the current price. So essentially, if you overpaid, it'll just pay you back the difference. It'll admit a token has been purchased and then return the token ID. Pretty straightforward, nothing too fancy there. Let's have a look at sell one. So when we sell one, we require the message.sender to own the token that they're trying to sell. So we pass in a token ID here. We require that the seller must have approved this transfer for it to have gone through. And again, we kind of get the median price to see what we can sell this at. And then it transfers that token from the sender to this address and then burns that token. So that NFT will be transferred to the address and then burnt. Finally, it will then send the value of the current price that has been calculated back to the sender and emit a token sold event. So we have basically 2 main functions here, buying and selling an NFT from this exchange contract. So let's have a look at the 2 oracle initializers. So we have a trustful oracle here. Let's take a look at how this works. So a trustful oracle is a price oracle with a number of trusted sources that individually report prices for symbols. The oracle's price for a given symbol is the median price of symbol for over all sources. So we can have a look. We can see there's prices by source. So this is a mapping to a mapping. So you would have an address which maps to a string which maps to a uint256. So you can see it's like the source address maps to the symbol which maps to the price. We have 2 modifiers here, only initializer, only trusted source for access control. We have an event here. We have a constructor, so we can see that it is going to set up a array of addresses to be sources, and it also has a enable initialization parameter to enable initialization or not. And then we have set up initial prices, which is a handy utility to allow the deployer to set up initial prices only once. So once this is done, you can actually just set the prices that each oracle has reported. So initially it's going to be, you know, the address, the symbol, and then the price. The reason there's 3 there is just because, again, back from the challenge description, there's 3 trustful reporters. So there's just some other checks here. So post price is external, and so one of these trustful oracles is able to update their price by posting to this function. Get median price is going to compute the median price and return that. Which, if you don't know what the median is, that's essentially if you have a set of data, it's the middle of that data. And if it's an even source, you get the two middle ones and then split them in two. Get all prices for symbols, so you want to get all the prices that have been reported per symbol, and then just some other helper functions as well. So you can see that this is how the set price function works. We can have a look at the compute median price and how that works. And then this is a sort function, which I imagine sorts. Yeah, it sorts all the prices that have been reported by the oracles. Cool. Okay, so let's have a look at the Trustful Oracle Initializer. So let's have a look here. It's very, very simple, just a simple constructor. The Oracle creates a new Trustful Oracle given the sources. And this true is from a constructor which enables the initialization here. And it sets the initial prices to whatever the sources, symbols, and initial prices are, and emits a new trustful oracle here. Okay, cool. So we don't really see anything too crazy on how we could exploit this straight away. And if we go back to the start, there were these weird kind of hex strings here, and we don't really know what they are. So let's go ahead and see if we can decode them and figure out what they are. So let's copy this, and I'm going to head over to just some handy site called ASCII to hex. And you could do this in code, but I'm just going to show it to you because it kind of makes a little bit more sense potentially if you see it visually. So I'm going to paste in the hexadecimal here and hit convert. And so this is going to convert this hex to its equivalents in all this other stuff here. So we've got a couple adds here as well. So we see the text is a bit random. This all looks fine. However, the keen-eyed of yours would notice that this is actually base64 encoded. So we can actually grab this ASCII text and paste it in the base64, and we can convert that again, and we can see here we get a text here. So this is a hex address, and if you kind of understanding where this problem is going, this is probably going to be one of the private keys of the Trustful Oracle. So let's go ahead and grab this one, and we're going to paste it. Oh, hang on, here we go. Let's close this. And so we now know that we have this as one of the addresses, and then we can decode the other one as well if we wanted to. So if we do that, if we decoded that, the first thing that we would get is here. So I'm going to start building up our exploit. Now, we don't know what the exploit is, but I just know that we're going to need these two keys. So these are the two keys. And if you do check them, they are the private keys of two of these three oracles. Now, what does this actually mean for us? The best way to do this is to actually look at the setup here from the author themselves. So they have the sources here, they have the deployer and attacker, they have the initial ETH exchange balance, some initial NFT prices, they're deploying all the contracts, and then it initializes the balance of the trusted source address to have 2 Ethereum each. And then the attacker starts with 0.1. And here's the interesting bit here. So this oracle is the Trustful Oracle that we deploy. And we're going to deploy the Trustful Oracle Initializer with its sources. Now, the sources are the 3 addresses up here, the 3 oracle addresses. They are deploying at dvNFT, dvNFT, dvNFT. Those are the tickers, and the initial NFT price. Now, if we look at the initial NFT price, it's 999 ETH. So there's definitely no way we're going to be able to purchase that with only 0.1 ETH in our wallet. And that returns the oracle address. So this is what the oracle is. And then we just deploy the exchange, which has the initial ETH balance of 9,990. And we then attach the NFT token as the exchange. So this is all basically setting it up. We have the oracles reporting their oracle price at 999 Ethereum. And I guess taking it back to general blockchain terminology, what an oracle is some way for the blockchain to get data from an external source, and it's meant to be a very, very trustful way of doing it. So things like, what's the price of the US dollar, what's the price of this stock, what's the current weather in this particular area. This is all not available on the blockchain, and so there needs to be a way for that to come in, and that's what the role of an oracle is within the blockchain ecosystem. Anyway, in this case, the oracles are supposed to report the actual price value of these NFTs. So the fact that we have two of these keys should really indicate how we can start to exploit this. Because they calculate, the contract calculates the price of the NFT via the median reported price by the oracles. Remember, there's only 3 oracles, right? So it's the middle one here that will have the price that has been reported at. So what we can do is, as we own the keys to these private wallets, we can act as these oracles, and we can then send a transaction to update the NFT price to be 0 and 0, or 0.1, because remember, in the main exchange contract, the amount paid in Way must be greater than 0. We could set it to 0 and send a little bit away, but yeah, that's just how we're going to do it. And once we've done that, we've purchased our NFT for a very, very small amount of Ether. We can then update the Oracle prices again, and what this will do is raise it all the way up to the price of the exchange, the exchange's balance, and we sell it, and then the balance is transferred to us. So that's the kind of approach of how this is going to happen. And I will look at the conditions here, right? So we need the balance of the exchange to be 0. We need the balance of the attacker address to be greater than the initial ETH balance of the exchange. And we need the balance of the NFT. So we need to have not any NFTs after we finish, and the NFT's price shouldn't have changed at the end. So we'll also need to reset the Oracle price at the end. All right, so how do we exploit this? So the first thing that we're going to need to do is generate the wallet signers within Ethers using these 2 keys. So we can see here we're going to generate a new Ethers wallet, provided key 1 and key 2, and then we have Oracle 1 and Oracle 2. We can sign and interact with our with these addresses. The next thing that we're going to do is we're going to create 2 more instances of the Oracle contract. Well, not a new instance. We're just going to connect to it as these 2 oracles. So essentially, Oracle 1 Trust and Oracle 2 Trust are the 2 oracles or contracts that we're going to interact with as these 2 oracles. The next thing we're going to do is we're going to create a really nice helper function. So this helper function is going to be called set median price. It takes an amount as a parameter here, and it will essentially, there's a whole lot here, but what's going to happen is we're going to see what the before price is. So we're going to go ask the Oracle, all right, what's the median price for DVNFT? And then it prints that out for us. Then we're going to update posting to Oracle 1. We're going to basically do Oracle 1.post price. Again, coming back to Trustful Oracle, we can see that there's post price here, which is only done by an only trusted source, which is defined up here as this modifier, which has the role of a trusted source role. So once we set the price, so we can come back here. We're going to print out the median price again, and then we're going to do it again with the second oracle, and then print out the median price after we posted those 2. So ideally, what we're going to do is post 0.1, 0.1, and then the third oracle, which you don't have the key for, is going to be 9999. Then the middle, which is the median price for the NFT, will then be 0.1, which we can then purchase. So, okay, after that, let's go ahead and set the price to 0.01. So, price to set, we're just going to, some helper functions here, and we hit the set median price as the price to set. This is going to call this function. And then, after that, we are going to connect to the exchange as the attacker. So we're going to start to interact with the exchange as the attacker. And we are also going to connect to the NFT token contract as the attacker as well, just so we have the two things we need to interact with. So now that we've set the median price to be 0.01 as the attacker, we have 0.1 ETH. So we can go ahead and purchase the NFT. So we await for the attack exchange, which is just the exchange connected to as the attacker. We're going to buy one. Let's have a look at the buy one, which doesn't take any parameters. However, it is payable and we need to make sure that we are paying something. So we're going to pass in an override with a value of the price to set. Now, why the price to set? Because that's the price that we just set the NFT to. So we want to send that exact amount there. Cool. All right. So now that we've bought one, we should expect that we should have a newly minted NFT here. So the first NFT that is minted is 0 with a token ID of 0. The reason that we know that is if we go here in token.safemint, this returns a token ID. And because no tokens have been minted since the initialization of the contract, it's going to be token ID number 0. Now, you could get this dynamically, but in this case, we can just set it to 0. Okay, so the next thing is we want to verify that we are the owner ID of this token. So we expect the owner ID to equal the attacker's address. And so once we've done that, we've officially got one of the NFTs and spent about 0.001. The next thing that we need to do is set the balance of the, set the new Oracle price back to the balance of the exchange. So this is going to be the second part of the exploit where we sell it back to the exchange at the price of whatever the exchange has. So we get the balance of whatever the exchange has, which is this.exchange.address. And the reason that we do this and not, where are we? It was the exchange initial ETH balance is because it already has a little bit of ETH from what we transferred it with that 0.1 or 0.01. So we're going to actually just dynamically grab that. So now we've got the balance of the exchange. We're then going to set the price of the NFT to the balance of the exchange. So we go price to set equals the balance of the exchange that we just calculated. And then we run that helper function called set median price, price to set. And that will go ahead and run that again. Then once we set the median price, we can go ahead and sell the NFT for that price. So we sell the NFT for the median price. So the first thing we need to make sure that we do is we approve the NFT to be transferred on behalf of us from the exchange contract. So we approve the exchange contract address to move our token ID of 0. And then we just go ahead and sell that token ID. Once that's done, we should have made sure that the exchange is then back to 0. But as with the final requirement of this challenge, we need to make sure that the NFT price shouldn't have changed. So all we need to do is set the median price. Where are we? Here we are. We need to get the price to be the initial NFT price that was set at the original, in the setup of this challenge, and then set the median price back to that price. And so what happens at the end of that, we've got all the ETH from the exchange has nothing, we don't have any NFTs, and the price of the Oracle is back to normal. So let's go ahead and run this and see if we solve this challenge. We're going to go yarn run and compromised. And you can see that passes no problem. So as we kind of go through the logs here, you can kind of see, all right, so here are the two addresses that here we go. So we've got key 1 and key 2. We got the two addresses, and we can verify that this one, so E92 is this Oracle address here, and 81A is this second Oracle address there. So that's definitely the one that we're looking for. So you can see that the current median price is 999 ETH, posting to Oracle 1. After we post to Oracle 1, it hasn't been updated. And then after we post to Oracle 2, it's then 0.01 ETH. I could have formatted this a little bit better, but you kind of get the idea. And then at the end, we can see that it is all pass and we've completed the challenge. I hope you enjoyed this challenge and walkthrough. If you learned something, please let me know. I'm going to go ahead and get the green tick by running the compromise challenge here. And I will catch you guys in the 8th challenge where we take on something new. Awesome. All right. See you later.